Good morning to all. So today we are going to discuss about the topic stepper motor. Okay. So this is a special motor used for small electronic applications and motor drives applications, everything. Okay. So why we need to go to the stepper motor in this question? So as we know that all the motors control are based on this closed loop feedback only. Okay, so feedback will give the accurate result of the entire operation. Okay, so if you are using the open loop system, so we cannot achieve the desired output. So only we are making this closed loop system. Okay. So in this stepper motor, so mainly based on this closed loop feedback control. So this will reduces the total system cost and simplifies the machine's design compared with the servo system control. Okay. So this stepper motors are mainly used in the PCS application, so not in the general application. So where we are changing the motor position from one angle to another angle or one direction to another direction. So in that particular places you can use the stepper motor. So this is a special machine used for many electrical and electronics applications, control applications, or mechanical automation application, everything and everywhere this is used. And what is stepper motor? So stepper motor is nothing but the brushless electromechanical devices which converts the train of electrical pulses applied to their excitation winding into precisely defined step-by-step mechanical shaft rotation. So we are applying the electrical pulse to input to the machine, and in that pulse which is based on the excitation, so which is going to rotate the shaft of the machine by step by step. That is the motive of stepper motor. The shaft of the motor rotates through a fixed angle for each discrete pulse. So we are applying discrete pulse. Discrete pulse means, so now we are giving a maximum pulse, then after a small interval we are not applying any pulse, then again we are going to apply the maximum pulse. So like that it will be changing. The shaft of the motor rotates through a fixed angle for each discrete pulse. So this rotation can be linear or angular. So it gets one step movement for a single pulse input. So we are applying the single pulse. So the machine shaft is rotating one step forward. Okay. So when a train of pulses is applied, it gets turned through a certain angle. The angle through which stepper motor shaft runs turns for each pulse is referred to a step angle. Okay. The shaft is moving from one step to another step is nothing but step angle. Okay. So normally the large step angle of the machine is 90 degree and the small step angle of the machine is 0.72 degree. Okay. So commonly used step angles are like 1.8 degree or 2.5 degree or some 7.5 degree and 15 degrees. So construction of this stepper motor. See this picture. So we are having the stator, we are having the rotor, everything's which is basic from your induction machine and synchronous machine. Okay. So everything will be there. Coil wire. We are having stator, shaft, ball bearings, rotor, magnet. So here we are using the permanent magnet. So we are not giving any separate supply to the rotor coil. Okay. So due to this precise control of speed, rotation, direction, and angle position, so these are particular interest in industrial process, control system, CNC operated machine, robotics, manufacturing automation system, and instrumentation. So these are the major application of the stepper machine. So normally the stepper machines are classified into three types: is permanent magnet stepper motor, then variable reluctance stepper motor, then hybrid stepper motor. Variable reluctance stepper motor. So the reluctance is varying from one place to another place. Okay, if your reluctance is varied means, so your stator and rotor, okay, stator and the rotor part we are having air gap. So this air gap is not uniform in the variable reluctance stepper machine. So the angular position of the rotor depends on the reluctance of the magnetic circuit formed between stator poles and the rotor teeth, or stator teeth and the rotor teeth. Okay, this is the teeth portion of your stator, and this is your teeth portion of your rotor. So between these two, we are having changes. So this rotation speed of your stepper motor can easily calculate from NR is equal to NS plus or minus NS by Q, where NS is nothing but a number of poles in the stator coil, and the Q is basically we are going to take in 3, or this is varying. So this 3 indicate the A, B, C, 3 phases of the machine. So for example, we are having 12 poles and Q we are taken as 3. So the rotor speed is either 16 or 8. So the construction of this variable rotor stepper machine, the stator has 12 equally spaced projecting poles where each pole is bound with an exciting coil. So these 3 phases are energized from a DC source with the help of solid state switches. So we are applying the pulses through this solid state switches. The solid state switches means that your MOSFET, IGBT, SCR. So these are the category of solid state switches. The rotor carries no winding and is of salient pole type made entirely of slotted steel lamination. Okay. So you have to mind it. Your stator is nothing but a core part and having the coil, but in your rotor carries a permanent magnet. It has no coil, and also the rotor poles are projected in the outside, and also your stator poles are also projected, so that only we can create the variable reluctance in between the stator pole and the rotor pole. Okay, so rotor poles projected teeth have same width as that of stator teeth. The number of poles on stator differ to that of rotor poles, which provide the ability to self-start and bidirectional rotation of the motor. Okay, so these are the things we discussed. So variable reluctance type. Okay, so this is the pictorial representation of your cross section and the working of your variable reluctance stepper machine. So we are having phases A dash, B dash, and C dash in the stator part. We are having 3 phases. So we are going to give the 3 phases supply through the solid state switches S1, S2, and S3. Okay. So first case in the rotor we are having either a 4-pole or either we are having 6-pole. So based on the number of rotor teeth from the stator speed. So your NR here we are fixing as 4. So see, we are having the A phases here, and we are having a coil number 1 or the pole number 1. A and pole number 1 are directly viewing. So now this rotor already having permanent magnet. So this stator we are having a coil. So now we are giving pulse to the stator coil. So this pulse, it may be a positive pulse or a negative pulse. If you are taken as a positive pulse, so this A part will be fixed as north pole, and also your one portion of your rotor will also be given as a north pole. So during that pulses, both north pulses are ripple each other, so that your rotor shaft is moved from this position to this position due to this repulsion principle. Okay, so now the second position is reached to about 30 degree. Okay, so after that, so at the time we are going to apply the next pulse. C dash were excited. So due to the C dash excitation, similarly this and one and will be attracted with each other, so that it will be changing. So what I am telling here means your A is a positive cycle and A dash is negative cycle, your C is positive one and your C dash is negative one. Okay, so your permanent magnet pole type which does not changing. If it is north pole, your C dash automatically is south pole. So north pole and south pole attract each other, then automatically it will be rotated. So that your rotor is regularly changing with a regular interval. So that we are having the calculation. So 360 degree we are having the over surface divided by a 4 pole, and we are having 3 phases, so that the angle of rotation is about, for a single pulse, about 30 degree. Then next one is permanent magnet stepper motor. The permanent magnet design motor is perhaps the most common among the several types of stepper motor. So that adds permanent magnet to the motor construction. So this type of motor, stepper motor, is also referred to as can stack motor or tin can motor. Okay, so the main advantages of this motor is low manufacturing cost. So this type of motor having 40 to 24 steps per revolution. So the construction is which is much not different from your regular stepper machine. So we are having a permanent magnet rotor here. We are having connector. So then corresponding stator winding we are having, stator body, then mountain plate. So this is only the difference is the rotor is permanent magnet here. So the stator of multipolar and its construction is similar to that of regulator stepper motor discussed above. It consists of slotted periphery on which stator coils are wound. It has projected poles on the slotted armature where the wound windings can be 2 or 3 or 4 pieces. The rotor is made up of permanent magnet material like ferrite that can be shaped of either cylindrical or solid pole type, but usually it is a smooth cylindrical type. The rotor designed to have an even number of permanent magnetic poles with alternate north pole and south pole. The working is we are exciting the stator winding that are excited by DC supply. It produces magnetic flux and establishes the north and south poles. Due to the force of attraction and repulsion between this permanent magnet, the rotor poles and the stator poles, and the rotor starts moving up into the position for which the pulses are given to the stator. So this working of the permanent magnet stepper motor. So the same what we are discussed in the variable returns type. So we are having a rotor and we are having the stator. Stator is excited by DC supply. Then separate single pulses were given for alternative time. So each and every time, so this place here south, then opposite will be north. Due to this attraction and repulsion principle, this will be rotating. Okay. So for this machine, the step angle can be calculated like this. We are having 2 phases and a 2-pole permanent magnet rotor. Then the angle of rotation of a single pulse is about 90 degree. Okay, then hybrid stepper motor, it is nothing but the combination of your both a variable returns and a permanent type rotor. So variable returns type and also the rotor will be a permanent one. So based on these 2 principles, this hybrid stepper motor is working. Okay. So the construction is similar that. So we are having stator and we are having rotor. Here we are having 2 phases and a 4-pole 6-pole rotor hybrid stepper motor given. So A dash is excited at a time and keeping B and B dash is unexcited. So due to this excitation, the rotor is permanent. So due to this attraction and repulsion principle, which is attracted each other. Okay. So the advantages is the standstill position. The motor is full torque. So no matter if there is no moment or changing position, it has a good response to starting, stopping, and reduction of position. There is no contact brushes in the stepper motor. It is reliable and life expectancy depends on the bearing of the motor. The motor rotation angle is directly pushed to the input signal. It is simple and less costly to control the motor. provide for the open loop control and responding to the digital input signal. Thank you.